All right, so let's take a look at chapter 10. Chapter 10 is deals with hypothesis testing. So let's take a look at what is hypothesis. Hypothesis is a general statement about property population. So um, think about, general statement about population mean, general statement about population proportion. Of course, it could go further. Somebody can make a general statement about standard deviation or variance, but we are not really interested in those in this class. So again, somebody makes a statement about, let's say, population proportion or population mean, and we have this methodology of testing their claim. So hypothesis test is a procedure for testing the claim about population proportion or mean for our purposes here. So we're going to look at how to state the null hypothesis and alternative hypothesis, what they are. We can identify type 1 and type 2 error, interpret level of significance. We're going to determine whether they use one tail, two tail tests, and find p-value, and make an interpret decision based on the results of the statistical test, and write the claim for hypothesis test. And here's an example. So hypothesis test is a process, as I mentioned, that uses sample statistics to test the claim about population parameter. Let's say somebody makes a claim. In this example, an automobile manufacturer advertises that its new hybrid car has a mean mileage of 50 miles per gallon. So they just made a claim about the mean, about population mean. Okay, to test this claim, a sample would be taken from the population. If the sample mean differs enough from the advertised mean, then you can decide the advertisement is wrong. And here's the basic logic in hypothesis testing. So when we are making statistical hypothesis, a statement or a claim about population parameter is made, we need a pair of hypotheses. One that represents the claim, and the other that represents its complement. And so we already know that, the claim and its complement um, um, uh, cannot both be true. So when one of these hypotheses is false, the other must be true. I'm going to give you just a little example of, a number line. Okay, so if, let's say this is my 2, okay, I'm going to create this interval. Okay, so 2, and then let's use our algebra and say that this is variable x is greater or equal to 2 here. That represents all this right side, and here x is less than 2 represents, let me use a different color here, okay, represents this. All right, so putting these together, these two are complements of each other, because all together they give you the whole number line. But so if I told you that, take a guess of the number, but that number is not here. Okay, so what would you say? Oh, if it's not in this interval, if it's not greater or equal to 2, then the number must be in this interval, right? It cannot be in both. So that's how it works with this hypothesis testing. That's what I'm trying to emphasize, is when you are setting up hypothesis testing, one of these hypotheses is false and the other must be true. Okay, that's very important. So notation, we have null hypothesis and alternative hypothesis. For null hypothesis, that's how you write it. We use the idea that something is less than or equal or greater than or equal. Notice that equal sign everywhere, right? And for these we just replace them always with equal sign, okay? So your null hypothesis is gonna have an equal sign in it. And your alternative hypothesis, where symbol we use, I'm sorry, it's H A stands for alternative. Some book, like your books, will actually put H1. Okay, and they have reasons for it, but I think A kind of nice because it corresponds to alternative. But again, your book does use different symbol, yet it calls it the same thing. It's H1. It's your alternative hypothesis. Notice that your alternative hypothesis contains signs like something is greater than, something does not equal to, something is less than. There is no equal sign, right? Equal sign is crossed. So must be true if null hypothesis is false. And the same, the null hypothesis must be true if alternative hypothesis is false. And these two are complement of each other. So again, just to cap, HO, null hypothesis, and HA. And then we have, H1 instead of HA, right? The book uses H1, but it's alternative hypothesis. And just list them in that order. And here you do the description, right? And I'm going to get to that in just a second. So here's your three scenarios to write. When you write your null and alternative hypothesis, this is how it's going to look like. Okay, do remember that your book uses 1 here instead of A. Okay, so you can have scenarios that null hypothesis is less than or equal some value K. And remember, your book actually suggests if it's the case, forget about the less than, just use equal sign for null, and then mu is greater than K. That's the first scenario. Okay, the second scenario is your population mean is again greater than or equal to some value, but we just replace it with equal for simplicity here. And of course, the other component has to be a complement, so it's less than some value K. So that's your second scenario, right? Your third scenario is that your population mean is the claim it equals to some value, and your alternative, the complement of this, it would be not equal. And this is important. So regardless of which pair of hypotheses you use, you always assume mu is equal to some number. That's why your book kind of makes you to write it in this way. But in reality, these two are complements, always complements, right? Let's take a look at how we would write the claim as a mathematical statement. So if the claim is given a school, here's where I am. A school publicizes that the proportion of its students who are involved in at least one extracurricular activity is 61%. Okay, here's how we interpret that. We set up two components, null and alternative. They said in the claim that it is. So that's why you put equal sign. So null hypothesis proportion is equal to 0.61. Okay, that's the word is. Then I'm thinking from there, and first of all, I'm gonna note to myself that was the claim right here, right? And the alternative has to be a complement. It would be not equal to 0.61. And so that's just how you set up the hypothesis testing. This step is very important because if you mess up the first step, everything else you're doing, all the multiple other steps, really don't matter. So pay attention that you can set up the right a hypothesis testing based on what you read in the claim. You always read the problem and reread it, and you start thinking through the claim to set up hypothesis testing. All right, so here's a third example. A company advertises that the mean life of its furnaces is more than 18 years. Okay, more than. Okay, there was no equal sign, so this is this component. It goes into alternative because that does not contain the equal sign. So once I know this, then I can fill in the null hypothesis because it's going to be the opposite. It's going to be the complement, and we always just assume equality. Okay, here. And yeah, we have to make a note for ourselves where is the claim because we will forget it when we go through the steps. So now I have a pair of hypothesis, null, and alternative. Okay, so the types of error. No matter which hypothesis represents the claim, always begin the hypothesis test assuming that the equality condition in the null hypothesis is true. That's what we assume. And we assume that equality condition null hypothesis is true. At the end of the test, one of two decisions will be made: reject the null hypothesis or fail to reject the null hypothesis. If you reject the null hypothesis, that means it's false. That also means that alternative hypothesis is true. Now, if you fail to reject the null hypothesis, that means the null hypothesis is true. And that also implies that alternative hypothesis is false. Because your decision is based on a sample, there is the possibility of making the wrong decision. Okay, so this is a very important. Please pause on this page. So, um, and just take it easy, but take a look that here's my null is true. This is my null is false. And here's what I actually do with that null. If I don't reject null when it is true, we made. So when it's true, we do not reject the null, right? Because it makes sense. So it's correct decision. Okay. When null is true but we reject null, you made type 1 error. Okay. Now, on the other hand, if your null is false and you do not reject it, here, if it's false but you do not reject it, you made type 2 error. And if null is false and you reject it, you made the correct decision. Okay, so this is explanation for type 1 error. Type 1 error occurs when the null hypothesis is rejected when it is true. And type 2 error occurs when the null hypothesis is not rejected when it is false. Alright, so here's a good example to demonstrate that. The USDA limit for salmonella contamination for chicken is 20%. It's important here. A meat inspector reports that the chicken produced by a company exceeds that. So the claim is very important. Is a meat inspector reports the chicken produced by a company exceeds. So its proportion is greater than 20%, right? That's what he claims. You perform a hypothesis test to determine whether the meat inspector's claim is true. When will a type 1 or type 2 error occur, which is more serious? All right, so let's set the hypothesis, set up the hypothesis testing. So they said that the proportion is greater than 20%, 0.2, right? This was the claim. It's very important. Alternative was the claim, and remember, greater does not contain equal sign. So on complement null hypothesis, the proportion is equal to, right? It's obviously complement is less than or equal to, but we always assume equality equal to 0.2. Okay, so let's take a look at the number line. So here's where, find here 0.2, and this side represents proportion is less than 20, and the right side um, represents the proportion is greater than 20%. Chickens exceed USDA limits. So so take a look first at visual representation and make sure that you understand that these two null hypothesis, alternative hypothesis are definitely complements. And let's take a look at the hypothesis themselves, right? We always have to remember where the claim was. So a type 1 error is rejecting null when it's true. And the actual proportion of contaminated chicken is less than or equal to 20%. But you decide to reject that. So not it doesn't seem like a big deal. Type 2 error is failing to reject null when it is false. The actual proportion of contaminated chicken is greater than 20%, but you do not reject null. So think about the implications of that. I'm going to pause here. You can read this again. Type 1 error is rejecting null hypothesis when it's true. The actual proportion of contaminated chicken is less than 20%, but you decide to reject that. Type 2 error is failing to reject null hypothesis when it's false. The actual proportion of contaminated chicken is greater than 20%, but you do not reject the null hypothesis. So with type 1 error, you might create a health scare and hurt the sale of the chicken produced who were actually meeting the USDA limits. With type 2 error here, think about the actual percentage was greater than 20, but you didn't reject no. So with type 2 errors, you could be allowing chicken that exceed USDA contamination USDA contamination limits to be sold to consumer. So a type 2 error could result in sickness or death. That is a very serious situation. So this is very important to understand this type 1, type 2 error in this context. All right. So level of significance. Level of significance, your maximum allowable probability of making type 1 error. And we use alpha for it. So denote it by alpha. We use lowercase alpha. By setting alpha level of significance at a small value, you're saying that you want the probability of rejecting the null hypothesis to be small. Commonly used levels of significance, here they are: 0.1, it's 10%, 0.05, it's 5%, 0.01. There's more, of course. I could have 0.08 would be 8%, but anyway, type 2 error is beta and doesn't show up too much in your textbook, but I just mentioned that. So okay, and after stating the dual and alternative hypothesis specifying the level of significance, a random sample is taken from population. Sample statistics are calculated. The statistics that is compared with the parameter in the null hypothesis called the test statistics. So this is important. The statistics that compared with the parameter in the null hypothesis is called the test statistics. For our purposes, think of test statistics. You're testing the claim of the population mean. That's your test statistic here. You're testing the claim of the population parameters such as, let's say, proportion of this from proportion of the sample is going to be your test statistics, and we don't really need this for our purposes here. And then the p-value, it's the probability, if the null hypothesis is true, of obtaining a sample statistics with a value as extreme or more extreme than the one determined from the sample data. It depends on the nature of the test. So again, take a look. The p-value is the probability, if the null hypothesis is true, of obtaining a sample statistics with a value as extreme or more extreme than the one determined from the sample data. Depends on the nature of the test. And remember, p-value, it's the probability, so you're talking about numbers between 0 and 1, small numbers. Okay, nature of test. You have three possibilities for type of test. You have left tail test, right tail test, two tail test. So left tail test would look something like this. Right tail test would look like this. You would have a right tail. And two tail test, hey, what? You're gonna have two tails. The type of test depends on the region of the sampling distribution that favors a rejection of null hypothesis. The region is indicated by alternative hypothesis. So let's take a look at the left tail test. And so take a look. You have you determine whether it's left, right, or two tail test by looking at alternative hypothesis. If the beak is pointing to the left, then you have a left tail test, and your p-value is to the left of test statistics. This value, test statistics, you find from formula, and of course you can use technology. Okay, to speed up the process, but first start with formula. So you'd find test statistics that comes, that has something to do with the samples, and then you look at your alternative hypothesis, and if the beak points to the left, that's your left tail test. Similarly, right tail test is determined by looking at alternative hypothesis on that component. If the beak or error, you can think of this is, if mu is greater than some value k, if it points to the right, then you have a right tail test, and your p-value is the area to the right of the standardized test statistics. This value you would find from the formula or tech. You have options calculator, StatCrunch, and Excel. Alright, and here's example of two-tail test. You again, we determine that's going to be that type of test by looking at alternative hypothesis. And yes, my p-value is split into into two equal portion. One is in the left tail, another is in the right tail, and these values are given identical with a different sign, as you can see, and this value is computed from formula. So if you know this value using formula and information from the sample, then your p-value is just the area trapped. And you can always figure out, if you need to find the p-value and you figure out test statistics, you know obviously what type of test it is. So you figure out 1/2 of it and just double it, because you have two-tail test and it's identical amount of area. So you can find one tail and double that area. All right, so going back to that example that we were talking about, a school publicized that the proportion of students who are involved in at least one extracurricular activity is 61%. We looked at this. This is two-tail test. So my p-value is going to be in two areas, and this is my test statistic value, or both of these, that I would have to compute using formula. We'll be talking about formula a little bit later. All right, so here's the left tail test, and that was the car dealership announced that the mean time for an oil change is less than 15. We looked at this, determines the left tail test. P-value is the area, but this is actually your test statistic value and determined from formula. Right, and the third, a company advertises that the mean life of its furnaces is more than 18 years. And by looking at the alternative hypothesis, we see it's going to be a right tail test. And guess what? This Z that traps this p-value, this area which we call p-value, to the right, because it's a right tail test, it's test statistic value. And we determined using formula. All right, now how do we answer, actually at the end of the process, how do we write our answer in correct form according to our statistical procedure here? So here you might want to come back to this slide again. So decision rule based on p-value, comparing p-value with alpha. If p-value is less than alpha, and then reject the null. So alpha is always given to you in a problem, and p-value you can figure out only when you know what type of test, left, right, or two tail, and also you figure out test statistics, that the value on, if you're in z distribution, that traps the area to the right or to the left. So that's what you would need to figure out the p-value. Alpha is given, and you can compare. If p is less than alpha, then reject no. If p is greater than alpha, then fail to reject or don't reject no. Then no must be true. Okay. So here's the how we phrase our final decision. If the claim is in null, claim can be in either one. So if claim is a null hypothesis and we reject null hypothesis, there is enough of evidence to reject the claim. If claim is a null but you fail to reject null, okay, there is not enough evidence to reject the claim. And then if claim is an alternative hypothesis and you reject null, we say there is enough evidence to support the claim. And then if claim is an alternative but you fail to reject null, there is not enough evidence to support the claim. That's how we do it, and that's the correct phrasing. So I want to make sure that you pay attention to this particular slide and you have a chance to come back. And now let's take a look at the steps for hypothesis testing. So here's step number 1. You set up, you read the problem, you identify the claim, you look at the claim, and you create a mathematical statement, or you claim mathematically and verbally. So in other words, you read the word problem, and you identify the claim and you interpret it in mathematical statement, and you record that null hypothesis and alternative hypothesis. Then from alternative hypothesis, you know if it's going to be right tail test, left tail test, two tail test. Then the level of significance alpha is given. Just need to find it, because they'll tell you test the claim at this level of significance. Then determine the centralized standardized sampling distribution, sketch the graph. I do want to point out that sketching is very, very important. It's helpful. I don't even know how to emphasize that. It makes a difference in whether you get the problem right or not. It is super important to sketch it. All right, then we need to, so that okay, so this was to determine the type of distribution. Sketch 3, calculate the test statistics, that's your 4, and you would use formula here. Okay, so I'm saying formula, but of course after you get comfortable with formula, you know, incorporate technology and it becomes faster. And so calculate test statistics and its corresponding standardized test statistics and add it to your sketch. And then if you're testing by the p-value, find the p-value, right? P-value is the area. It's, if you're right tail test, it's in the right corner. If it's you have a left tail test, it's in the left corner, or it could be split into two. Okay, that would be your step 5. Find, use the following decision rule. Is the p-value less than or equal to the level of significance alpha? If yes, reject no. Interpret the decision in the context of original claim. If no, fail to reject no. Alright, so then let's take a look at the formula that would help you find your test statistic value. So formula can be written in several different ways. Again, your book will not use Q, it will use 1 minus P. But again, it's P, I'm going to focus on this one right here. P, which comes, P with a hat, which is proportion from the sample, right? Because you took a sample to test the claim. So you should know this, or it should be given to you. P with a hat should be given, minus P, population P, and the claim is about the population proportion, so you should know that. And then it's P times its complement divided by N, and your book will say, will write this formula like this. P times 1 minus P, right? That's the complement divided by N. N is the sample size. So again, it's not a big deal to put it in a formula, but again, with technology, once you figure out technology, it kind of gives you this this value very quickly without you doing computation. So it's easier and faster. That's called your test statistic. So you also need to verify that n times p is greater than 5 and n times its complement greater than 5. State the claim mathematically and verbally identify the null and alternative hypothesis. It's this. And identify alpha. It's given to you. Use table or calculator or TID 3 to 4 to find the critical values. So critical values is based on alpha. So if I know I have two-tailed test, I'm gonna take my alpha over 2 split into, it's also area, kind of like a p value. Alpha, the critical values are those values here. Let's put them z values, right? That trap this alpha over 2 if I have a two-tailed test. So those are, we can find it using our table, or we can find it using our technology, and also StatCrunch works for that too. And that would be your rejection region. The alpha, that area is your rejecting of the null hypothesis. Find the standardized test statistics using the formula we are talking about. Make a decision to reject or fail to reject the null hypothesis based on where this test statistics falls into. So if, let's say, I have this, let's say again I'm going to draw a rejection region. Let's say I had two tail tests, and this is my alpha over 2 area, right? And this is my z-score that traps this area, right? This rejection region area. And let's say I computed this value test statistics. Let me use different color. And if it falls into one of these regions, if the number, you compare this, if it's in here or it's in here, it tells us to reject null. So null must be false and alternative hypothesis must be true. If it falls somehow into this region, then fail to reject null. So basically your number line determines here what you're going to do with the null hypothesis. Let's take a look at example. A researcher center claims that less than 50% of U.S. adults have accessed the internet over a wireless network with a laptop computer. In a random sample of 100 adults, so here's important information. N equals 100. At 39% say they have accessed the internet over a wireless network with laptop computer. At alpha equals 0.01, this level of significance, is there enough of evidence to support the researcher's claim? So first we're gonna verify that n times p is greater than 5, n times q is greater than 5, but remember that these values, n equals 100, p, its sample p with a hat is 0.39, and alpha is 0.01. We're going to test it and read the claim again. So research center claims that less than 50% of US adults have access internet over wireless. So what are we going to do? We're going to first set up this claim. And let me actually go here. Less than. This is the claim. This is where we started. And then of course I built from there. I assume that here that proportion for population is actually equal to 0.5%. The alpha was given at 0.01 level of significance, test the claim. All right, so we also know that alternative hypotheses tell us what type of test. It is left tail test. So we go to our picture here and we can draw rejection region based on alpha. So take a look. If alpha is 0.01, you can actually find your this score, but using your table or your calculator, whatever you've used before, StatCrunch, you can find this negative 2.33. This is your critical value. It marks the rejection region. Now, then I'm putting the information given into the formula. 0.39 was the p with the hat, right? 0.5 is population proportion, and computing this value, again, I do emphasize that the technology is much faster, and I find this test statistics. This is test statistic value. Now take a look. If I compare them on the number line, this negative 2.2 is negative 2.2 versus negative 2.33. Negative 2.33 is more negative, so negative 2.2 does not fall into rejection of the null hypothesis region. So we don't reject the null hypothesis. We fail to reject the null hypothesis. that means it might be true. At this level of significance, there's not enough of evidence to support the claim. Support the claim was an alternative hypothesis that 50% of adults have access internet um, over wireless network with laptop computers. So that is our conclusion. So this is procedures, do step by step. Let's take a look at the next problem. Research Center claims that 25% of college students think a college degree is not worth the cost. You decide to test this claim and ask a random sample of 200 college graduates, okay, whether they think a college degree is not worth it. Of those surveyed, 25% reply yes. So that's your P with a hat here. At alpha equals 0.1, is there enough of evidence to reject the claim? Again, what is the claim? Average searcher claims that 25% college graduate think the college degree is not worth the cost. That 25% of college graduate think the college degree is not worth the cost. So first we verify these, n times p, make sure it's greater than 5. Then we collect our info. Remember, we have everything given the analysis testing. Okay, the claim that proportion is 25%. What's the opposite of that? What's the complement? Not equal. But this is also determines what type of test. Two-tail test. Okay, here's a picture. Two-tail test. This was given to us in a problem. Now we need a rejection region, so we split this into two. So you technically have 0.05 in one end and 0.05 in another. Okay, so that's how you use the information, that's the area, to find the critical region, to find these values which correspond, they call critical values. They correspond to critical region. The area is 0.05 in the left, 0.05 in the right, but the critical values you would find from the table, from StatCrunch or from TI 384. And then you collect the information that was given. You use the formula or technology to find this test statistic value. That's what it's called, test statistic value. And you see if it falls into reject the null hypothesis region. It doesn't. It falls into fail to reject null hypothesis. Okay, so if you fail to reject null hypothesis, that must be true. The null hypothesis must be true, but it's also attached to a claim. So at a 10% level of significance, there is not enough of evidence to reject the claim that 25% of the college graduates think the college degree is not worth it. And again, but we can do the same testing but using p-value and alpha. And your book goes through both of these testing. They test the same thing. So but you cannot bypass learning both of the methods. So with p-value, remember we already mentioned, if p is less than alpha, then reject null. If p is greater than alpha, then fail to reject null. And we are comparing really two areas. Remember, p-value is the area, and alpha is usually it's given to you in a problem. It's also the area. And p-value you figure out by test statistics. It's the area that trapped by test statistics to the left, to the right, or into corners. If let's say this situation, if the p-value is 0.0237, what is your decision if the level of significance is 0.05? All you have to do is compare these two. And if the p is lower, you reject the null. Okay, on the other hand, the same p-value but alpha is 0.01. Compare these. Now your p-value is greater than alpha. If that's the case, you should fail to reject null hypothesis. Um, and I'm just repeating myself for the left tail test. The P is the area to the left tail. For right tail test, the P is the area in the right tail area that's that is separated by test statistic value. For two tail test, the P is the area in tail of two times the area in tail of test statistics. So you just find one corner and multiply times two. Okay, example. Find the p-value for left tail hypothesis test with test statistics already given to you. Somebody computed for you. Z equals negative 2.23. So in order for us to find the p-value, again, you can use your table. You had to know that it was left tail test, right? So you sketch the picture and you put your test statistics on the horizontal line. There it is. And you use your table or calculator or StatCrunch to find the area to the left. And then, of course, here we want to uh, decide what to do with null hypothesis based on alpha 0.01. We just compare the p-value and alpha, and here's p is greater. We fail to reject null. Okay, let's take a look. Another example, finding the p-value for two-tail test with a test statistics of 2.14. Okay, so they give you only positive value, but you know it's two-tail test. So decide whether to reject null hypothesis at the given level of significance. So first, sketch a picture. And if you know your test statistics here is 2.14, find the area to the right or negative 2.14 because we know symmetry, or you could have found the area here. It doesn't really matter. But then make sure you double that area, and that's your p-value. And then you are just comparing the p-value to alpha that was given, and here's p is lower, so reject null. Okay, now so after you're testing the claim by proportion, next sections are gonna deal with testing the claim about mean. And testing the claim about mean, the procedure is very similar, but in your book in 10.3, you're dealing often with small samples, so you're dealing with t-distribution, but the logic is very, very similar. So I'm not gonna go over all the same thing. You can have left tail test, right tail test, two tail test, set up hypothesis testing. It's all the same. But yes, you need to find critical values in the t-distribution and use t-test to test the mean, the claim about the mean. And use technology to find p-value or table, of course. So let's take a look at some things. Now, identify the level of significance. Remember, it's actually given to you in the problem. Identify the degree of freedom because you're dealing with t-distribution, and in our section here, degree of freedom is always n minus 1. Okay, find the critical value using the table or technology will work in the row with n minus 1 degrees. If you have a left tail test, you want, so you use your knowledge from chapter 9 that you just completed on I'm assuming you know how to use the t-distribution, and so you figure out, you do have to know if you have left tail test, right tail test, or two tail test, but use your table to figure out the critical regions. And let's take a look at this example. Find the critical value for the left tail test given that alpha is 0.5 and n is 21, sample size 21. We'll have to find degree of freedom, which is 21 minus 1, 20, and you take your alpha 0.05 and use your table. You have it in the left tail, so find that critical value, which in our case is 1.725, and you use your table and knowledge from chapter 9 to do that. Okay, find the critical region of negative t and positive t. In other words, you have two-tailed test here. You have two-tailed test alpha. The area split into two pieces. You have 5% and one, 5% another, and your n is 26. So you should be able to look at the table and now have knowledge from chapter 9. Figure out these two values. Figure out one, and you have two-tailed test. It's just gonna be another one. It's gonna be with opposite sign. Okay, let's take a look at the formula you will need to use to test statistics. So test statistic value, kind of very similar like what you did with proportions, but it's a different formula here. It's x with a bar, which is mean from the sample, minus the population mean, that's what the claim is all about, divided by standard deviation of the sample over square root of n, and degree of freedom, don't forget, is n minus 1. Again, the same process, state the claim mathematically. Okay, that's this. Identify the null and alternative hypothesis. Alternative hypothesis tells you what type of test you have. Specify the level of significance or find it in it's given to you. Identify degrees of freedom. That's n minus 1. Determine the critical values from alpha, right? Use alpha to determine and the type of test you have, left, right, or two tails to determine critical region. And of course, use technology or table, whatever you need. Determine the rejection region. What you do is find the test statistics using this formula, and then see if it falls into reject the null hypothesis or not. Make decision to reject or fail to reject the null hypothesis, and then, of course, if t is in the rejection region, reject the null. Otherwise, fail to reject the null. Interpret the decision in the context of original problem. Okay, and here's a good example. So a used car dealer says that the mean price of 2008 Honda CR-V is at least, that's very important for us, at least 20,500. You should suspect this claim is incorrect. You suspect this claim is incorrect, so you think it's not. It's at least, so it's 20,500 or more. And you find a random sample of 14 similar vehicles that has the mean price of 19 something and standard deviation of 1,084. Is there enough of evidence to reject the dealer claims? At alpha equals 0.05. They gave you all the information here you need. Assume the population is normally distributed. That was important. Then, after I read the problem, I go back to the claim. The used car dealer says that the mean price is at least. It's at least. It's 20,000 or more. Mean is greater or equal to 20,000. So once you do, that's the claim. So you set up that first component right here, and then alternative component, and this tells you it's going to be left tail test. Once you know this, you take your level of significance given, sketch the graph, and find the critical value, like this one, that from t distribution that has 0.05 area to the left. Okay, then you And of course, don't forget about degree of freedom because you're in t distribution. Then you use the formula or technology to find this um, test statistic value. And of course, information comes from the sample here. And then in our case, this value falls into reject the null hypothesis. So if you reject the null hypothesis, but think about it, it was connected to the claim itself. So at the 5% level of significance, there is enough evidence to reject the claim that the mean price of 2,800 CRV is at least 20,500. All right, let's take a look at the next one. An industrial company claims that the mean pH level of the water in a nearby river is 6.8. So the claim that the mean is 6.8. Is important in mathematics. You randomly select 19 water samples and measure the pH of each. The sample mean and standard deviation is 6.7 and 0.24 respectively. Is there enough of evidence to reject the company's claim at alpha equals 0.05? That is the level of significance given. Assume the population is normally distributed. Okay, we start into the claim. Claim that the mean is 6.8. Okay, sample, what was the sample size? N was 19. Okay, then what else? Standard deviation is the mean. Okay, mean of the sample is 6.7 and standard deviation is 0.24. Okay, so we got everything. So claim that equal sign tells me it's going to be two tail tests. So all okay, so this is our first step. Null in hypothesis. Claim is identify. Level of significance. Then we use our table or technology and alpha 0.05, degree of freedom 18 to locate critical values. Critical values again come knowing that I have two tail tests. I'm splitting 5% into both corners, so I get 2.5% in each corner, and so I figure out the critical value. Then I gather the information given and put it in the formula to find the test statistic value. And then, as you can see, the test statistic value falls into fail to reject null. Okay, and if you fail to reject null, the null must be true, and so is the claim. So what we say at the end, at the 5% level of significance, there is not enough evidence to reject the claim that the mean pH is 6.8. And let's take a look at the last problem here in this section. A Department of Motor Vehicles office claims that the mean wait time is less. It claims less than 14 minutes. A random sample of 10 people, that's your n equal 10, has a mean wait time. Sample mean is 13, and with standard deviation 3.5 and alpha equals 0.10. And what is the claim again? Claims the mean time is less. Mean time is less than 14. Okay, there's no equal sign, so we know it's my alternative, and so the null is going to be mean equals 14, right, or greater than or equal to. Okay, so we got that, and the claim is here, and it tells me it's going to be left tail. All right, we could actually put that information into technology, and this is the point. So this is our job to do right here. We did that, and if you put it in technology, it will give you p-value very quickly. And so you can alpha is given to you in the problem itself, so you can also compare p-value to alpha. If P is greater, fail to reject null. Okay, if you fail to reject the null, that null must be true. Therefore, the alternative hypothesis must be false. Or we would say, and so is the claim, right? At the 10% level of significance, there is not there is enough of evidence. There is not enough evidence to support the office's claim that the mean wait time is less than 14 minutes.